In this video, we will learn how to represent the graphs in the programs. Means like when you are writing the programs for any application which you want to represent as a type of a graph, then you can use either of these representations actually. So we can represent the graphs using adjacency matrix. So matrix, we all know that it will be in the form of rows and columns actually. So rows and columns in the matrix can be like vertices. So each entry is the weight of edge between the vertices. So here, if weight is not existing, then we represent the edge using 1. If no edge is there between the vertices, we'll represent with 0. The next one is adjacency list. Graph is a collection of linked list actually. So the number of linked list is equal to the number of vertices in the graph. We will see an examples for in both the cases. So first one, I am considering this example graph. Now here we are having A, B, C, D, 4 vertices and different edges. And you can observe that I have not given any weights for this particular graph. So first adjacency matrix, if you consider, as I already told you, we can have vertices as rows and columns. So here if you see like A and A and A, that is from A, this rows is like source vertex, destination is like columns actually. So here A to A, if you say like because we don't have any self loops, all diagonals will become 0. Now, because this is an undirected graph, it will be a symmetric matrix. So, A to B, we are having edge. So, A to B, this cell will become 1. And similarly, B to A, because it is undirected graph, B to A will become 1. So, A to C is 1, A to D is 1. So, first row will be similar to first column. So, you can fill accordingly. And then B take B to A we have already marked. B to C no edge is there, so we'll say 0. B to B no self loop, again it is 0. B to D is 1. So second row is equal to second column. And then C. C to A we have already represented. C to B no edge, so 0. C to C no self loop, so 0. C to D is there, so 1. C to D is 1. Then D. D to A we have edge, so 1. D to B edge is there, so 1. D to C edge is there, 1. D to D self loop is not existing, so it is 0. Like this we can have adjacency matrix. Then adjacency list. So here if you see like 4 lists will be there, depends upon the number of vertices. So from A we are having B, C, D, all are connected. So what we'll do, A to B, C, D, then X. Then considering B, we are having only edges to A and D. So B to A, D, X. So X is nothing but null pointer indicating the end of the list. So see here to A and D. So C, A, D and null pointer. D is connected to all A, B, C. So we'll say D, A, B, C null pointer. Like this we can find the adjacency list actually for a given graph. We can represent adjacency matrix in the other form also. That is ABCD, that is vertices as rows and edges as columns. Now here in this graph, E1, E2, E3, E4, E5 are names to the edges, not weights. Okay. Now, because A is incident on E2, E3 and E1, E1, E2, E3 will be 1 and it will be 0 for E4 and E5. Now coming to the second row, that is B, because it is incident on E2 and E5, E2 and E5 will be 1 and the remaining will be 0. Now coming to the C, that is incident on E1 and E4. You can see E1 and E4 columns are 1 and remaining are zeros. Similarly, D is connected to E3, E4 and E5. So E3, E4, E5 columns will be 1 and remaining will be 0. Now is undirected graph actually. How will you find the degree of a vertex? So it is easy, very easy actually, because A, how many ones are there in the row? 1, 2, 3. 3. 3 edges are connected. So the degree of A is 3. Similarly, if it is B, 2. 2 ones are there. So degree of B will be 2. What will happen in the case of C? 2. And D, 3. So degree of A is 3, B is 2, C is 2 and D. Now, coming to the adjacency list, how will you find the degree? Again, it is also simple because it is undirected graph. You can say like B, C, D, three vertices are there. So degree will be 3. Similarly, B, A, D, 2 are there. So B, 2, degree of vertex B is 2. Degree of vertex C is 2. Degree of vertex D is 3. Now, if you go here also in the similar fashion for adjacency matrix, if we are representing rows with vertices and columns with edges also, it is simple. Degree of A is 3 edges. So 3. B is 2. C is 2 and degree of D is 3. Like this we can calculate. Now let us see an example in the case of directed graph. So here if you consider this graph, we can see like how adjacency matrix will come. So A to B is there, A to D is there. So A, B will be 1, A to D will be 1. Then consider B, B to D only is there. So B to D, let us fill it as row wise. Automatically columns also will be filled, right? So C to A is there, C to D is there. So C to A is 1, C to all are incoming edges. So everything will be 0. Okay. And because D is a source index, if you see as a row, so D is fourth row is all 0. Now coming to your adjacency list, so because A is connected to B and D, we will have A, B, D, null pointer. So B to D and null pointer, C to A and D null pointer, D nothing because no income outgoing edges are there. So null pointer. Because it is a directed graph, how will you calculate the indegree and outdegree? First, let us see in the adjacency matrix. So, if you go with the row wise, it is outdegree, okay? Because A is a source, if it is row wise, it is outdegree. So, outdegree of A, 2, outdegree of B, 1, outdegree of C, 2, outdegree of D, 0. In degree, you can go with a column. So A column 1 is there. So in degree of A is 1, in degree of B is 1, in degree of C is 0, in degree of D is 3. Like this you can find in the case of adjacency matrix. Now coming to your adjacency list. The number of nodes in the list gives you out degree. So B, D are there. So 2 is the out degree for A, 1 in the case of B, 2 in the case of C. Null, nothing is there in the case of D. That is 0 in the case of D. That is out degree of D is 0. Now, how will you calculate the in degree? It is a bit complex in the case of adjacency list. In the lists, all the lists together, you have to find where A is existing, means like number of times A is existing. If you see, first element should not be considered. A, only 1 is there, right? So in degree of A is 1. In the case of B, only 1 again. So B is only 1. C, you can see it is not existing anywhere. As a source only you are having. In the destination, it is not existing. So in degree of C is 0. And in the case of D, you can see in the find of list A, you can see in the list of B, you can see in the list of C. 3 times it is existing. So, in degree of D is 3. Like this, you can calculate the in degree of vertices in the case of directed graph. Okay. Thank you.